All right, so here we are in chapter 2 on describing change rates, and this is section 2.3 on rates of change, the notation and interpretation. All right, so we have some labeling here. So we have the average rate of change is the AROC. It measures how rapidly, on average, a quantity changes over an interval. Okay, now this can be attained by calculating the slope of the secant line. So if you remember, we've been looking at slopes, and so here is like if that's our tangent point of tangency, then we can make a slope between that and some other point on the line, and we can find the secant line, and we can find the slope, from that. Okay, so that's going to give us the average rate of change, and it requires 2 points, usually that point of tangency and some other point. Now we can get the instantaneous rate of change as well, and that's when we use the tangent line. Okay, so that measures how rapidly a quantity is changing at a certain point. And it can be obtained by calculating the slope of the tangent line at a single point on the continuous smooth curve. So the key thing is this has to be continuous and smooth. And then you just draw your tangent line, and then you find the slope of that. Okay, so that's how we have been doing it a little bit in the last section, and that's how we're going to continue doing it here. All right, so if you remember from the last section, the rate of change of a function f at a specific input a is written as f prime a, and it's noted as the derivative of f at input a. So we were calling it a derivative a little bit in class. And so when it's desirable to express the input variable along with the derivative notation, this is how it's done. df dx, and this means evaluated at x equals a. So we're taking the df dx, that's the derivative, evaluated at x equals a. Okay, so for a smooth continuous function f with a specific input a, the f prime of a, which is the same thing as what this is all saying, is used to represent the following quantities, all of which we can interchange. So we can do number 1 or 4 or 3 or 2, all of them mean the same thing. So that means the derivative of f at a, it means the slope of the graph of f at point A, comma, sub f sub a. So basically that slope of that tangent line. And that's also what the next point also says. So it's slope of the graph at that point, or the slope of the tangent line at that point. And then the rate of change of f at a. Okay. So all those are interchangeable, and they all basically mean the same thing. So, interpretations of derivatives. Because the rate of change is measure that describes something that is in a process of changing, we have to remember it must be in the progressive tense, which means we are ending on ing. It's increasing or decreasing or changing or something. And then the sentence should also include all the things we talked about before: when, what, how, and by how much. All right, so let's look here. So we have the flight distance. It says the function p, and again, we don't know anything beyond what this is saying. So it says the function p gives the number of miles from an airport that a plane has flown after t hours. All right, so basically, we've got a plane that's flying so far, and it's going to be p is how far it's flown over x or t, I guess it was, hours. Okay, so it's flown distance of p over t hours. Okay, so what are the units going to be on the derivative? Well, remember the derivative is going to have the output of p divided by the input of p. And so if we think about that output of p, distance, well, distance is in miles, so it's going to be miles per, and output of that is going to be, or actually the input I should say, is we're putting in t hours, so that's hours. So basically, what are the units? It's miles per hour, because after we divide, it's just going to have 1 hour in the denominator, and then we'll have whatever fraction of miles in the numerator. Now, what common word is used for the p prime at 1.5? Well, that's going to be speed, miles per hour. That's how fast you're going. So we can think of that as speed. Okay. All right, so here we have airline sales. So it says the function T gives the number of one-way tickets from Boston to Washington, D.C. that a certain airline sells in 1 week when the price of each ticket is P dollars. Interpret the following. All right, so it looks like we have plugged in P is 115. So it says basically we're going to sell the price is rather 115. The price when it's $115, the airline is going to sell 1750 tickets from Boston to Washington D.C. in 1 week. So let's write that when the ticket price is $115. The airline is selling or going to sell. Let's how are we going to write this? We got to write it right the first time. The airline sells 1750 tickets from Boston to we'll just call it DC so we can shorten it in 1 week. Okay. Now, this one is saying, okay, well, our ticket price again is going to be $115, but now we're finding the derivative of it. So we need the instantaneous amount. And so this is what is changing. It's changing at this rate. Okay. So what we're going to say here again is when the ticket price is $115. Now what's going to happen? The number of airline tickets, basically, because now we don't know how many we sold. It's just we know it's going to be increasing or decreasing, and it's going to be increasing by that many. The number of tickets, airline sales from Boston to DC in 1 week is, now we have to remember it has to be in that ing first, so it's going to be increasing by, now how much is it going to be increasing by? Well, it's increasing by 220 tickets per dollar spent. So it's going to increase by 220 tickets per dollar for the ticket price, or however we want to say it. So per dollar basically of ticket price. Okay. Now, what about this one? Well, it's going to say exactly the same thing as the last one. And so, it's going to blah, 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 is, and then it's going to be 125, blah, 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 blah. And it's increasing by 22 tickets per dollar of ticket prices. Okay, so instead of writing all that out again, we have a lot of dots, and then the key thing is it's changing to 125, and it's changing to the 22 instead of the 220. Okay, all right, let's stop there, and we'll come back for more.